Hello! Today we're going to be converting this AltspaceVR World that was used as the original Cornerstone Church campus in AltspaceVR to VRChat. This is intended to be more of a long-winded, longer form video, so that way hopefully you won't get lost in it. The many steps there are involved to being able to convert not only the different dealing with the different Unity versions, but the different render pipeline and the different shaders and making sure everything is Quest compatible. As you can see, all of this is pretty simple. AltspaceVR worlds tend to be lower polygon and lower texture counts due to limitations of what it took to make a main event, being, you had to have like a world 20 megabytes or less, whereas with VRChat, the upper limit is 100 megabytes or less for Quest compatible worlds, and I do not think there's an upper limit for PC worlds, but it's not very practical to have to load 2 gigabytes every time when I go to a PC VR world, so most people stay around the 200, 300 megabyte limit. So the first thing that you're going to want to do is you're going to want to go ahead and unzip your world file. So I've already unzipped it. It's in this folder, and it might still have the plugin that was previously used to be able to preserve it. Great. So you go ahead and open up the Unity hub, and you would normally have to manually add it after unzipping. So you go to the file location and you go ahead and open. I just click on that to make sure the folder name should be the root directory if you can. So I click on it up here, but also if you just double click it here and then just hit open, that'll work just fine. So then it's going to go ahead and load, and you'll get most likely this error talking about like, oh, this specific file, could not be loaded, which was the original plugin to be able to preserve these files. You can go ahead and continue and not have to worry about that. And now we have our panel. So right now we're in the package manager panel because it recognizes that this plugin is no longer attached or a part of this, but you can see in the main world environment, here's the world. Yay, it's been preserved with every single light and everything, because this was originally had baked in lights. Unfortunately, I haven't found a good way to be able to take worlds from AltspaceVR and add baked lighting inside of VRChat, because a lot of the way the World Preserver worked, it created a lot of meshes with non-finite values. And the version of Unity we'll be using doesn't support baked lighting with meshes with non-finite values. And I haven't taken the time to figure out how I could fix that in Blender. So yeah, the first thing now that you've opened up Unity is you're going to want to go over and go into the scenes directory and right click the one that has a bunch of numbers on it and export package. This will create a nice really tall list of every single object or texture or whatnot that's inside the scene. This helps get rid of a lot of the extra kit objects that are not needed and will make loading between Windows and Android versions later a little bit faster. But if you were planning to add more kit objects that you weren't previously in the world, you would then want to instead go to Assets, Export Package, and that would export everything, including a bunch of kit objects that were never used in your environment. So anyways, but I like reducing clutter, so I'm going to export from scene. Make sure your include dependencies are checked. And I like going ahead and exporting it to like the root directory of wherever you're going, and then calling it what it is, like Cornerstone VR low poly. Low poly. You can see it's a quite small size on this one because we don't have many textures. So the next step, after you've gone ahead and created that file, that package with all of your assets that you wanted to preserve, you're going to need to go ahead and download the VRChat Creator Companion, which is the new entry point for creating things for VRChat. It seems like a package manager to me, where if you Google search it, you'll most likely find this as your first website. And the Creator Companion is available at this location, Truly, which requires an account to do. So you can then go ahead and download the Creator Companion app there and install it. It'll walk you through like making sure that you have the correct Unity version downloaded, or if it doesn't find it, it'll download the correct Unity version for you. So time to go ahead and open up the Creator Companion app, which is called that. Don't try typing in VRChat in your Windows because it will then go ahead and pull up VRChat instead. And so I think that's kind of funny that they don't put the word VRChat in the Creator Companion app. So you're going to go ahead and in the top right, create a new project. I always do world project with Udon Sharp because then that allows me to do more coding later, and there's almost no harm in it. But you could still also choose world project itself. Just don't choose avatar project, whatever you do. Go ahead and name it whatever the world name you want. Cornerstone VR low poly. But if you're ever planning on working with multiple VR platforms, I highly recommend you put abbreviation at the end of what platform you're working with. So in this case, VRC for VRChat, but if you were to do spatial, you could do an abbreviation for that. Or if you were to do something for Rec Room, when their studio beta version becomes more public, then you would want to have like RR for Rec Room at the end, so that you can keep these projects consistent and just move assets between each other. Gonna go ahead and create project, make sure you had it in the correct folder, and you'll be greeted with this panel that you can always get back to by hitting the Manage Project button. So there's the easy quest switch. This will be necessary to be able to do the quest shader switching that we'll do later. And then the VR World Toolkit is useful because it has a nice debugger that'll show you like information about world size. The audio link is not very useful because it only is if you want to be able to have audio in the world space affect the movement of objects, for example. And so that's really useful for DJ environments, but we're not going to be doing that today. When you go ahead and hit it open, it's going to take about 3 minutes to open because it's going to load in all the different packages, and each of them require their own sets of caches and dependencies and DLLs to be cached. So sit back, grab a cup of whatever your favorite drink is, and watch the loading bar. While you do that, you can feel free to move the package you recently exported into the folder that you just made, so that way you can always load it back in later. So Control X to cut and Control V to paste. Ta-da! We now have our environment. Woo! So this is a blank VRChat space. We're going to go ahead and do the first thing is to import our package of assets. So go ahead and import custom package. If I can click and navigate over to where you place the package and open. It'll show you a nice import Unity package panel, and go ahead and just leave everything checkmarked and hit import. Because we already know that everything is required since they were all dependencies from that scene from before. Then you're going to wonder, where is everything? So go into scenes and then double click the scene, and you now can see your scene. Congratulations. You now have the whole environment correctly placed in the correct version of Unity 2019.4.31 F1, and you already have all the packages and dependencies you need to be able to upload at any time. Normally, you'll be greeted with this TMP importer question, because if you ever place a label in the environment, you can see we have a label over this communion, but guess what? The text here isn't here because the package necessary for that is requesting to be imported. So go ahead and import TMP Essentials, which is an abbreviation for Text Mesh Pro, but you don't need to import the examples and extras. You can go ahead and exit. And you're going to say, I still don't see the text. So what you need to do is you just save, Control S, or File Save. Go ahead and close, and then go ahead and reopen the project, which I'm going to do from the main page of the VRChat Creator Companion app. And you'll notice that this time it opens a little bit faster because all the packages are already pre-cached. And you'll notice that it has the little symbol for Text Mesh Pro, and then it has the text to appear like normal. Great. The next after that is to go ahead and add the basic component that allows people to spawn in. VRC World, and then you type that in your project panel, and then under In Packages tab, you'll see that there's this prefab called VRC World. So you can drag and drop that in below at the bottom. I try to keep all new objects I add to the environment at the bottom, just so I know what was originally in AltSpace and what have I been adding. This object will have a few defaults built in. So like if you want to increase the walk speed or the run speed or the strafe speed, you can always do that. And wherever this object is placed is defaultly where your spawn point is. So I'm going to go ahead, and because when I built this world in AltSpace, I had the spawn point at 0, 0, 0, the spawn point will also still be at 0, 0, 0. And just to let you know, the default spawn point for any world in AltSpace was 0, 0, 0. And keep in mind, the direction that the blue arrow is facing supposedly is the direction that you'll be facing when you spawn. So if you ever wanted to change that, you could just change the Y rotation so that the person's like facing away or something like that. Let's go ahead and add post-processing. So VR World Toolkit, the package makes this really easy, where you just go to post-processing, set up post-processing. It'll complain that you don't have a camera object to use, and so go ahead and create that and hit continue, and you'll then see now a post-processing volume and a main camera volume. This just makes, in my opinion, everything look more filmatic, and I like it when things look more filmatic. The main camera you see here with this little camera preview, go ahead and reposition it however you want so that the camera preview is what you want to be the thumbnail of VR, the scene when people join the world in VRChat. Do something like that, because what do people think of when they think of a church? A cross, a stage, and those crazy church chairs. Great. So we've added our camera and we've perfectly placed it. If you want, you can add reflection probes to be able to, especially indoor environments, would reflect something other than the sky. So you can see like this wall right here, and even the flooring is reflecting the sky because of how smooth these textures are or shaders are. But I'll be changing that so they're not reflective, so I'm not concerned but just keep that in mind that you might have to look into adding reflection probes if you want to do more of that. Okay. Next is to select everything on the far left besides the objects you've added. So you can do that by going to the topmost object, holding down, moving down to the bottom, holding Shift, and then clicking the last object you want selected. So you can see that's all selected. I'm going to stop these particle effects. And we're going to go ahead and set the layer from, right now most of them are set to pick up no environment to default. The reason they were set that way is in AltSpace, the layer 14 meant that layer could be teleported on. And if it was not on that layer, people could not teleport on it, kind of thing. So the problem is that the layer 14 is used for in VRChat as the pickup no environment layer, which can give unwanted side effects. Go ahead and for all prefabs, go through. Prefabs are the ones that are in blue, generally speaking. And you're going to be looking on the inspector panel on the right-hand side to see if there's any sort of collision mesh collider. And you're going to want to remove those because the mesh collider that's on the root of the object tends to be how people would interact with the object in the AltspaceVR World Editor, not how people would interact, not how people would walk on the object. Just to show you as an example of how to remove a collider component, you would just go into this little tilde up here and then do remove component. And then it just goes away. An easy way to be able to do multiple at the same time is you can press F2 to rename the object, Control-C to copy, and then click anywhere, click up in the top of the hierarchy, paste, and then you can see all those objects, and then you could then use shifts to select them all. And then you can go over here to the component and then hit like remove component. So that's how I would do batches at a time of getting rid of those default box colliders. The reason why you would do that is because a lot of the trees had these giant box colliders around them, making it so that were placed by and uploaded as kit objects, and that would make walking around trees and such very difficult. Fix the skybox. So sometimes you'll have scenarios where the skybox has like the top on the bottom or the bottom on the top. And so you'd have to go ahead and go into a photo editing program like GIMP to go ahead and move those squares in the correct place. If the skybox is not loading, what you would want to do is go open the ASVR, the AltspaceVR Unity project, Unity Hub. So remember, this is our original ASVR version of the world using the newer version of Unity. Apparently it's already open in the background. An easy way to find the skybox would be go rendering, lighting, there we go, environment, and then you can click skybox, and then it will select the skybox in your panel down here. Normally I go into the root of assets and I create a folder called hotfixes, so that way I can just put all these files that fix something in during this port in there. So then drag and drop, and then you would get the original skybox working in the asset. Because one time when I imported the package, the skybox wouldn't work at all, and I needed to open up the old ASVR project, drag and drop it over here. If the issue was the texture wasn't working, you could get to the texture by clicking on the skybox that you found in the lighting panel, and then clicking on the image, or like whatever the square image is, over on the right. And then again, you would be able to bring it over by dragging and dropping, and there you go. But in this case, we want to drag and drop to hotfixes. And then you would be able to go ahead and drag and drop it into the spherical position in the skybox, and then you'd be able to replace the skybox by drag and dropping into skybox there. So now that I've walked you through that, walls being inverted, you could open the PNG in GIMP. In this case, we're going to go ahead and right click on here, show in File Explorer, and then I would go ahead and open up GIMP, drag and drop the file into there because I find it easier than doing file open. And then you would use the selection tool, and instead of leaving it like this where you can select everything, you would then be able to select fixed, and you'll notice when I zoom out, it shows this fixed box of a certain size. If you had a cube map, which was the type of skybox I had when this didn't work, or when like the bottom was inverted with like the top of the sky, I went ahead and used this size at position 0, 0, 0, 0. And then I went first thing, selecting the first two squares, use tools, transform tools, and then I think it was flip. So now I'm using the flip tool. If I use control, it'll flip vertically. If I don't use control, it'll flip horizontally. In my case, I needed to flip it vertically, so I held control and then move the position of the selection box, which again, we'd have to click anywhere to create it. Set the position the second time to 0, 4, 0, 9, 6. Which is much farther down because this was a much higher quality cube map. And flip horizontally by not holding the control key. So once again, you would go to tools, transform, flip, click once, and then it would flip those two cubes of the 6, or 2 squares of the 6 squared skybox horizontally. And then the last time you would make one more selection, set the position to 0, 8, 1, 2, 1, 9, 2. And then you would go back to your tools, transform, flip, hold control, and flip vertically. So, and then export as PNG, file, export as, export. And then you could replace. And when I hit replace, it'll come up with one more dialog, and you can just leave the defaults export. Cool. But we don't need to do that because the skybox is working for that kind of thing. And then you would be able to go ahead and select your skybox in the inspector panel and take that new exported PNG and drag and drop into here to make sure it's all working. So there's a quick question of why is there this crazy seam? And because I'm using a panoramic skybox instead of a cube map skybox, it adds this little seam. So there's 2 ways to fix this problem. One is to, when you go find the skybox, which is lighting, skybox, touch the texture, and go select the texture, you can uncheck mark generate bitmap and hit apply, and boom, the seam goes away. However, VRChat really does like having generate bitmap and streaming bitmap enabled. And so another way to do this is, instead of having it be handled as a 2D texture, the texture shape could be switched to cube and the mapping be set to latitude, longitude, layout, cylindrical. And then if you go ahead and hit apply, you would then just go back to your skybox, go back into your inspector, and then have to re-drag and drop your new cube map into the skybox after you switch the shader to cube map. So cube map, and drag and drop it in there. See, no seam. If when you were using geometric shapes like spheres or cubes, and you'll find everything that was manually placed as prefabs down, below your environment. There is a chance that the object for some reason got lost in a sense. And so in that case, what you would have to do is you would have to decide, like, oh, let's say this plate was missing its mesh render. You would go select the little button next to its mesh, and then you could search for, like, let's say it was a sphere that it was missing. Sphere. You could then just select sphere, and then that would bring its mesh back, which is nice and convenient. But that's only if you're dealing with geometric shapes. Another thing to keep in mind is when you're playing the game, so you can hit this play button at the top to do a basic VRChat test. You'll notice sometimes there'll be objects like doors that you have to walk through. And so those objects, like for example, I can't walk through this door because there's a collision box from this stage blocker. So I'm going to go ahead and remove that because that's not useful to us at the moment. And also we can be more precise with our collision boxes than the stage blocker. But like, it's very common for people to have placed a kit object that was in like a door that was intended to be walked through. Like, they usually have a sign above it saying like, walk through me. And so then you would have to manually exit play mode, go over to that crazy object, and then you would go ahead and find the colliders and then go ahead and remove them. So remove component. So we get to witness me slowly removing components. So you'll start to notice that my cursor is going across the screen a lot already to be able to interact with things in the inspector panel. So what I like to do is I like to move the inspector panel to the left side of the scene view, along with any other things that I put with the inspector panel, like the lighting. So that makes it really convenient where now I just can click here and then go halfway across the screen. I think that matters a lot more when you're dealing with larger display sizes. So now if I go ahead and test again, I should be able to walk on stage and stuff like that. So I highly recommend that you test to make sure that you can walk everywhere you want to be able to walk. So my collisions are still working. That's kind of convenient. You'll still be able to sit in VRChat. It'll just be very weird for people who are not used to falling down into the ground slightly, as opposed to being able to click on a chair object. You'll notice that this is white over here. And the reason for it is because it used to be a water shader, but as you can see, the water shader is currently not working in this version. So we'll have to go ahead and add a VRChat capable water shader, which I'm sure will be beneficial to a lot of other people too. So I seem to be able to walk everywhere, which is good. Keep in mind that if you have vertical walls, sometimes people can like jump up the walls. So now what you're going to want to do is you're going to want to go in and switch to the Android version and start making sure everything's ready for the Android version, which the reason why it's called Android is the Quest VR headset under the hood is an Android device, an Android phone in essence, that they've repurposed with a display and extra sensors to be able to do virtual reality. I should mention that it takes a long time to load switching between Android and Windows, but there's a huge time saver that you can find by going to Edit, Preferences, and then if you go under Cache Server Global, you can go ahead and select version 2 local mode, and then I set mine to 20. Check cache size. If I go ahead and do that, it should say 0 because I haven't switched between. Yep, cache size is 0 because I haven't switched between Android and Windows. You can set a custom cache location on like a hard disk if you really need to and browse to that location. And you can clean it whenever you want. The default is your username, app data, roaming, Unity cache, and all that. So I really appreciated it. I hope you do. You can now go ahead and close this panel to actually switch to the Android version. Go ahead and go into File, Build Settings, select Android, and while you're here, set texture compression to ASTC and switch platform. This will make it so that the compression on Android for textures will look a lot better in the long run. And now sit back and relax. The number of textures really makes a big difference on how long it takes to re-cache everything for the Android version of Unity. And it's finished. Woo! So go ahead and you can close the build panel because you're not going to have to use it much. Control S to save your changes so far because it's healthy to keep saving whenever you remember. And then we're going to go ahead and double check that everything's set up by going into Edit, Project Settings, and then you'll notice in this little panel that VRC Mobile is set to Android. Yay! Under the Quality panel. So that means either the VRChat Creator Companion app or one of the respective packages is working as it should and making a separate quality setting. You're going to want to bring in the window Easy Quest switch, which will make another panel, and you're going to want to dock this, in my opinion, permanently, but that's how I like to do it. Oh man, it's wider than I remember in 720p resolution. Go ahead and hit the button to set up for this project. And the first thing you're going to drag and drop is the post-processing volume. Because guess what? The post-processing volume doesn't work in Android. So the Easy Quest switch is a really easy way where you drag and drop any sort of item, and it'll allow you to toggle the different properties of that element that you drag and dropped. So that on PC, for example, it's active, but then when you're in the Quest mode or Android, it'll make it disabled. You can always force to be able to switch between Quest and PC by hitting the force apply PC settings or the force apply Quest settings. And you can always remove Easy Quest switch from the scene if you need to, and blah, blah, blah. You can also mess with these other settings. This is the biggest step when it comes to converting worlds to VRChat, is to go through every single shader and make sure everything works in VRChat. So the easiest way is if you select everything by hitting Control A and then you hit Select Children, it's going to expand to every single object, which is really useful. So now if we slowly go through this, and let's see if I can make this smaller. So you notice when I scroll down to the bottom here, it's got door wood, door plate, and door window as 3 different materials, and they're all the standard shader. What we're going to want to do is for every single one of these, we want to enable GPU instancing. Luckily, I would already had that enabled for this template. And then after that, you're going to want to drag and drop them over here. And then you're going to click this little bulb and then switch them, type in the word light, or copy and paste it is what I'm going to be doing repeatedly. And then select VRChat Mobile-Standard Light by double clicking on it. And to remember that you've changed the door plate shader, so you don't need to do it again, you would go ahead and go click on the standard, paste light, and you can either hit the enter key or click on standard light in this case. Sometimes if the texture is emissive, you'll have to recheck mark enable emission in the light version of this. What this does is normally the standard shader has the ability to do things like transparencies, but Quest Android, doesn't have the ability to do transparencies well, and so without tanking frames per second. And so the standard light version that VRChat made really helps out in optimizing the performance. So then you're going to ask the question, well, then what do we do for door windows? Because as soon as I switched it from standard, which right now looks kind of weird. I mean, yeah, you can see through it, but great. It's pretty reflective. If I paste this in here and switch it to light, it becomes no longer transparent. So for anything transparent, what you're going to want to do is you're going to want to create a new material, you're going to want to create a new texture and I use GIMP to do so. GIMP, ta-da, file new. You're going to want to make the texture 1 by 1 because you're just going to make this a solid color for performance reasons. And then you're going to go ahead and bring in your paint bucket, select whatever color of window you want. So we'll do this like nice cyan blue. Paste in here. Set the opacity you want to whatever your desired opacity is. So I'm going to set mine leaning more towards transparent at 15. And then I'm going to go File, Export As, make sure it's PNG. And we're going to call this glass. And you're going to want to export it into, your hotfixes folder. So we go ahead and hit export. Export. Minimize. So now we have our new glass color opacity set. We can then go back on this lobby door that we were working on. For something that will work. The only thing that I know for sure will work is VRChat mobile particles alpha blended. Technically, on their website, they don't list it as supported, but because this was a shader created by VRChat, I'd imagine they would like to continue supporting it for a long time. So once you switch it to that, drag and drop your glass into the texture, and you'll notice that now the texture for this door is semi-transparent. I'm going to tease that blue is still really harsh, and so I can quickly iterate on it by coming in here and either reducing the opacity and then going to File, Export As, Export, Replace, Export. And then when I switch back to the Unity, it will then show the new version, but it still looks really blue. One thing to note is the shader alpha blended. It doesn't care about layer Z or what appears first and last. So although I do use it for tree branches often because normally those need transparency, you'll sometimes notice when you're looking at the trees, the leaves that are farther behind are sometimes layered on top of the layers that of the leaves that are closer to you. This heavily improves the performance of the transparency because they don't have to worry about in what order they're rendering these alpha textures, but sometimes can be things will just feel off. So Silent is one of the guys who makes shaders for, VRChat a lot. He has a really good water shader. He supposedly has Filament as a real-time physically based render engine for Android and designed to be as small as possible and as efficient as possible on Android specifically, probably to support, for the Quest. And I believe Filamented provides transparency, so feel free to look into that if you want to try that as another option for transparency. But I know that because this is a particle shaders are meant to be really high performing. So I'm happy with that. I'll expect the Quest to run really well. So what's really convenient is every single object that uses those shaders that you just changed will keep the change. What's also convenient is because the door window, I don't want to use the standard transparency. I'm just going to leave the shader here. And when I go back to Windows, it will stay as the, VRChat mobile particle alpha blended shader. If I drag and dropped it into here, I could have it switch back to like filaments filaменted shader, or I could have it switch to the standard shader and then be transparent on the standard shader settings, and then it would layer them correctly. But I want the experience, might as well allow it to be high performing also on the PC client. Anyways, that's just how I think. So I use the arrow keys to be able to move faster through here. I'm going to make a recommendation that you can move your project panel and your console panel out of the bottom to be able to see more vertically if you have very little screen real estate to see all the different shaders. You'll notice that the particle shader doesn't have a enable GPU instancing, and that's fine. We just need to keep going through here and make sure that every single object in this project, the shader has been converted. And so in this case, because this door has a different handle, the bar handle, it had a different material, which also needs to have GPU and instancing enabled, which most of the time doesn't, but I made this template, so I had that enabled. You're going to drag and drop door pull, or whatever the material name is. You're going to click on that little circle on the far right for the quest shader, and then you're going to paste in the word light, and you're going to then select the light shader, and then you're going to come back here to door pull and change it to the light shader. And if you had any emissions on that texture, then you would enable emission. How I'm able to quickly go to objects is if you click on the object in the hierarchy on the left and press the F while you're in the mouse is over the scene view, it'll take you right to the object. Because all of these are just different variations of the same model, if I've changed it for one of them, the shader, it'll change for all of them. So I only have to check unique ones. It might be recommended to listen to music while doing this, or listen to a podcast, or listen to a sermon, or listen to a book, an audiobook, because it can get quite tedious, or talk to a friend on some sort of chat program. Because it can get very monotonous over time. You could even take a phone call. You can check if you already did something, because normally they'll be twirly down, or they'll say the word VRChat in the front because you changed the original color. Now, the smarter among you might realize that a lot of these solid color materials don't really need to be using such fancy shaders like standard or standard light, because it doesn't have a normal map to add detailing or height maps or really anything fancy. I could be using a diffuse shader like VRChat Mobile Diffuse, and it would look just as good. Still allow me to get GPU instancing. Still, I'll use the same base RGB texture. That's 1 pixel by 1 pixel. And if I was doing this for permanently, I would do that, but I want to make sure that I'm living out a good example for people who may have AltspaceVR Worlds who do have normal mapping or metallic colors or whatever, or who don't have GPU instancing enabled. Yeah, because see, you can have a metallic smoothness material, and you can set your metallic and smoothness here, and you can have emission, like let's say someone had a spaceship with an emission texture, you would be wanting to use the standard light under VRChat Mobile. But that's why I'm getting this warning saying, hey, since you don't have a normal map, consider using something like the VRChat Mobile Diffused or light mapped or whatever. If you did figure out some way to bake in your lighting, obviously you would go to VRChat Mobile Light Mapped instead of diffused. But that's the only difference I've noticed. And to be honest, I might go back and instead of having to switch between standard and Quest for standard and standard light for PC and Quest, I might get rid of all these and have them all be forced to diffuse, since that would make this world very performant in both, since it doesn't need to have the overhead of what a standard shader provides. Now, another thing you might notice is that that all these materials seem to have like a shine to them, which in the original it didn't because of the shader that was used. The preserver didn't necessarily preserve every single all the shader settings. I believed I used like a mobile. Originally, when I uploaded this to AltSpace, I believe I used the mobile diffused shader, but the preserver automatically converted them all to the standard shader instead of the mobile one, which kind of surprised me. Not only that, but it set the smoothness all the way to 1, making everything look shiny. And so you might want to go ahead and lower that smoothness all the way down to 0, or check on your details. Now, if someone uploaded a standard shader, it would usually keep all of the settings of like what normal map or whatever, or what emission it has. And if it was a custom shader, it would go ahead and leave it as the custom shader, like you can see over here, but most likely the custom shader won't work because you're moving from the universal render pipeline. I'm going to leave my smoothness at 1 for now, it'd be fun to see what this looks like, because I plan on going back through this and all these shaders and switching them out as VRChat Mobile Diffuse for the final version. But I want you all to see what it looks like and how long it takes to go through all these files. And this is like a relatively simple one in my opinion. I don't even know all the different shaders. And so I'm just a normal person trying to share what little knowledge I seem to have obtained. This is another example of where I used particle shaders in the past. And since mobile particles alpha blended is in the VRChat one, I'm going to switch them over to that, but not add them to the EasyQuest switch, because I want it to be this, I want it to be high performing also for PC. So enable GPU instancing. What that does is that improves the performance of the that basically improves the performance of the world. There's 2 ways where the graphics card can batch materials. One way is to do static batching, where it's like, I know that this object isn't going to move, so I can know ahead of time like if this object is behind one object or not. And so that would be static batching, which you can set at the very top of objects by going here and then batching static. However, that requires, I've had problems where some of the objects would actually look fully black no matter what I could do when it was statically batching. So I have a theory that happens due to some of the meshes being non-finite. The meshes with non-finite values can't be statically batched. So, as the alternative, enabling GPU instancing allows it to render multiple objects in the same step, even if they're moving in the scene. So that's really cool, and it's like the next best thing that we can do. If you switched out the shader first here to light, you'll notice that for PC, it'll say it's currently standard light. Well, we can type in the word standard and select standard, and then we know it'll go back to standard. That's another way to do it. Or you could just, let's say you switch this, you can always just switch it back by hitting Control Z, or you could, and then drag and drop it. Multiple ways. I just noticed that when you search for the word standard, you get multiple options, whereas if you search for the word light, you don't. So it's easier to do it in this order where you drag and drop it first and then switch it to light. This is an unlit color. So again, VRChat, the official list of what shaders are supported is pretty short in VRChat, but the unlit shaders, in my opinion, are very, very simple. And I would be surprised if they didn't continue to supporting them, on the Quest headset in the long future. So yeah. So I encourage you, if you see anything like unlit color, unlit texture, you can just leave those. If you switch out it to light and then notice the enable GPU instancing is unchecked, you'll go ahead and check mark it now, and it'll still apply when you switch back to PC on the standard shader. So don't feel like you have to Control Z it back to when it was the standard to be able to enable GPU instancing. Since I use the unlit transparent cutout texture, I'm switching them to VRChat mobile particles alpha blended, especially for these, because although they are transparent, what's intriguing is they have something directly behind them. It's not like there's multiple alpha particles or alpha blended particles on top of each other. So I'm not worried or concerned at all about like it just being able to layer correctly what's in front and what's behind when doing the alpha stuff. Just wanted to point out, these are examples of materials that don't have enabled GPU instancing enabled. I usually try to do GPU instancing first, so just to make sure I don't forget, because sometimes it's easy to not look for that check mark. So this is an example called, wait, let me go to the light. This is supposed to be a light fixture. And when you'll notice that in standard, it has emission on and the color is set to white. If I go ahead and switch it to standard light, you'll notice that because enable emission is not checkmarked, it gets darker. So go ahead and checkmark it again, and it works just fine. And you'll notice that if I switch it back to standard, it keeps the emission checked. And if I switch back to light, it keeps the emission checked now. I think the reason for that is in the metadata, this variable is called enable emission, whereas the standard only just has a check mark for the variable named emission. So that's why I'm guessing it doesn't carry over that one check mark. But it does carry over the emission color. Just FYI, any changes you make to material, like let's say the smoothness of this pole or whatever, if I set it to 1 and go to standard, it will keep the smoothness as 1. If I set the smoothness down to like 0.33 and switch back to standard, it will keep that smoothness at 0.33. So for most settings, between the standard shader and the standard light shader, they will stay the same. For stage blockers, what I normally do is go ahead and switch them to VRChat Mobile Particles Alpha Blend, even though they're inactive. And they'll never be active because the script that would make them visible doesn't initiate or doesn't exist. But I leave them in the project file because when they're inactive, they aren't going to hurt the performance that much. And if I ever wanted to in the future, I could use it as reference for where I'd put like a stage blocker in the future. A great example of a particle effect. I had a little fire at the campfire. So if we go into VRChat, mobile, what was it? It used to be additive, mobile particles additive. So we can just do the same one, VRChat, mobile particles additive. And it looks pretty much the same, but now it's VRChat mobile optimized. Photos that have the unlit texture, you can see here. Although this one doesn't have a photo, it's just kind of blank right now. You can just leave the unlit texture shader untouched for both PC and Android. And then you're gonna wonder, but TextMesh Pro mobile sounds like a weird shader, you know? Should we change that? And my answer is no, because it is designed for mobile devices already. Technically, it would be better to go ahead and make a 3D model of a word in Blender. Let's see if I can find examples. This room B is a mesh created in Blender. Because that's going to be using the standard light shader, we can have confidence that it won't be deprecated in the future, and it will continue to be supported by VRChat. But TextMesh Pro is so commonly used by people in Unity that we can have confidence that it will stick around for a while. Of course, you can make changes to your environment. In this example, I'm going to go ahead and get rid of Melly's Christian Coffee's house. So that way people don't get confused in this environment. Save all your hard work. While you're going through all of that, it's useful to you're like, oh, I remember in the previous world, this rooster was pickupable. Let's Google search how to make an object pickupable in VRChat. Oh, you just do pickup, VRC pickup, and then with that component, you can decide if it's kinematic or not. Is kinematic under the rigid body component, which gets auto added when you add a VRC pickup component, makes it so that the object will only move when the player moves it. So you don't have to deal with physics or gravity or whatever. It's very common for pillows in VRChat to have is kinematic on. However, in this case, because I want people to be able to throw this rooster around and have fun with it, I'm going to leave that unchecked. The VRC pickup allows it to be picked up, and you can change what text appears when you mouse over it. So in this case, the use text could be rooster, if I can spell correctly. And then if you want this object to be local, you just leave it as is, like where if someone picks it up, they are the only ones seeing themselves pick it up and move it in the space. But if you want it to be synced, you would then want to do the VRC object sync component, which I believe is, you can then allow collision based on the owner. You want to leave true. That is something I'm going to apply on all of these roosters. Something to be aware of is that when you add the VRC pickup component, it will automatically change the layer to pickup. And so just don't be alarmed if you notice that the layer is not default. So that's normal, and that allows it to be handled differently. Like let's say you wanted mirrors to not show the pickup objects. Then you could set a colding mask, I believe, to the pickup layer and uncheckmark the pickup layer, and that wouldn't show anything in the mirror that's moving. An easy way to make them all pick up is you can select a bunch of them by clicking on the top one, holding shift and clicking on the bottom one, hit add component, and then you would type in VRC pickup, and notice, and then you can also type in VRC sync so that the object is synced across all users, and you'll notice that the components have been at least added. Multi-object editing is not supported on the VRC pickup script. So if you wanted to do something like, say, change the little tooltip that comes up when someone is trying to select it, you would have to go through and manually change that individually per object. Still streamlines things a lot better to be able to add those components to all the objects at once instead of having to select every single object and add the component. Of course, you can always test to make sure you can pick up these objects by going ahead and hitting the play button at the top and then running over to your objects to then go ahead and pick them up. I will admit that I should probably increase the run speed, and you would be surprised that so far most of the AltspaceVR worlds that have been made are much larger because they had the teleport function. And so because of the largeness of the worlds, it's sometimes really beneficial to be able to allow them to... Well, looks like they're spawning and falling through the table. Time to debug this. But anyways, oftentimes I'll go close the menu or exit play mode. I'll go into the VRC world and I'll double the walk and run speed to compensate for the lack of teleporting in a AltspaceVR world designed for AltspaceVR. When you add the VRC pickup and the to an object, it gets a rigid body and it is set to use gravity, correct? What happens is if the mesh collider is not convex, it will not collide with anything. So you have to make it convex. Unfortunately, that does make it so any like dips in the model will not will not work in essence. So like you can see the green outline of this chalice showing how it's going to be treated a lot more like a cylinder than it would be treated like a normal object. If you tried to like stack them with their thinnest parts on top of each other, it's not going to work. This applies also to what it collides with, where you need to have your table also be convex. Just make sure that if you want your objects to not fall through a bunch of other objects, just make sure they're convex. Or you can manually go ahead and add a collider component, because there's a bunch of different types. There's the box collider you could use capsule collider, and you could use sphere collider. I'm not exactly sure what terrain collider is, but you could use wheel collider. You don't want to use the 2D colliders though, because that's for side-scrolling video games. You could use a box collider in combination with capsule collider to make it so it could stand upright and stuff, but yeah, you can see now that's what the box collider looks like. But I'm gonna stick with convex, and we are lucky because you can select a bunch of objects at the same time and say, I want all of you to be convex. And look, now we can pick up our wafers and pick up our chalices and stuff like that. So another shader fix we get to do is the water. Unfortunately, any water assets used in Altspace probably won't work because they're custom shaders. A recommended one for VRChat is this Quest Noriben Water. So Noriben made it. You can get it from this URL address at the top. Apparently, a lot of people use Booth to be able to host their assets. Some will, like this Noriben's Water, will allow you to download for free, but then if you feel like it, you can donate. And a lot of the people, as you can see in this case, created the assets from other countries. And so it's apparently really efficient on Quest, so you won't have to worry if your Quest version will fall apart using this water. So we're going to go ahead. The only thing to be aware of is that you need to create an account to be able to access Booth, and they use PixV or something like that for their account system. I've already downloaded it, and it downloads as a Unity package. So we're going to go ahead and go into Assets, Import Package, Custom Package, Noriben Quest Water, and go ahead and open, and then you can go ahead and import all. And now that we're done mostly going through these objects and looking for the shaders, I'm going to return the console, and the project panel back to the bottom of the screen, just because that's more standard of how things are set up. I'm going to close the Easy Quest Switch tab for now, because I want to be able to see what I'm doing a bit more. So you'll notice that this is silent, clear water, cheap, custom, and if you really want to, the variables for these custom shaders typically are saved. And so you can actually go ahead and copy and paste whatever values that you think is important. So in this case, and like put them on like a notepad or something. So I'm going to go ahead and open up a notepad, put it right here. And I'm going to keep track of the scroll, because I want to remember what direction I had the waves scrolling. Noriben Lunch, Noriben Quest, and then you can see all your materials. So I actually moved the Noriben Quest water shader up to the top, and then delete the Noriben Lunch because it just feels redundant. My theory is that the water uses vertex displacement to make the waves, and this mesh I have has very few vertexes in it. You can't really see it. I mean, you can see in the reflection there's some sort of texture that's moving across, but you can't just one for one replace a flat plane with this water shader texture. So you have water to place in a world, right? A lot of the kit objects had the water in squares already, so it should be a pretty one-to-one experience replacing water like this one by just placing down the squares. In this custom model, though, there are segments where the mesh was conformed exactly to the terrain, and there was no expectation for the mesh to rise and fall. And so, as you can see here, there's some limitations where it looks like the water is not connecting right now. But when we're working with scaling the square in the future, we should be able to scale it in such a way that the parts that shouldn't be shown hide behind the terrain, and the parts that should collide with this water down here at some point. Because these meshes didn't have many points in the center, the waves don't rise and fall. And so basically what you have to do is you have to add the mesh that comes with Noriben Quest Water Shader. So you go into this mesh, you go to the bottom of your hierarchy, drag and drop in here, press F to find where it is, which is usually at the beginning, and then you can move it to line up with the water that you want to replace. Sometimes you can click on the water that you want to replace, and there's a little where the 3 dots are in the top right of the transform. You can go ahead and copy a component, and then you could then paste those component values and it would place it appropriately. However, because the scaling isn't perfect or something, that doesn't seem to work well in this circumstance. I've just had other worlds where I can do that, and I just had to modify the scale. It looks like this mesh, the C-plane mesh, currently has no material, or the material named no name. I want to go ahead and replace that with a material that has a slightly different color, so that way I can start off with this being about the same height as the previous water. So then I can press the R key on the keyboard to bring up this scaling tool in the scene view. And I can go ahead and scale up until I get about the size that I want. If you grab from the center, it'll scale uniformly, which I believe is important because otherwise the waves would look squished in one direction. Now the big moment, instead of having this material outer wall, we go to the material under Noriben Quest Water Shader. Drag and drop our Quest water there. And boom, we now have water. Now you can also see that this water has rises and falls. Even though we lined up the original plane with the height of the previous plane, which hides underneath this board, you can see the water above the board. So in the end, to compensate for the movement of the vertices, you're probably going to have to finesse with hiding this rising action underneath the board. And that does cause some issues over here. So what you can do to fix that is underneath your Quest water, you can go ahead and reduce the wave height. So we're going to reduce it to 0.03. And then that will reduce how much the water goes up and down. So then we can raise it up just a bit until the water would be seen over the normal spots. And you'll notice that the direction I'm going in is wrong. I'm going to go ahead and rotate this by 180 degrees. That's the easiest way, in my opinion, especially since right now, all the different, if I change the values inside this Quest water, it will change every, the material for every single material out here. If you really wanted, you could go ahead and Control D, and then you could duplicate a second Quest water and a second PC water if you really want to have different wave heights or wave scales per segment. But I'm not about to do that. So it's easier to rotate the object and instead of changing the values of what direction, because I believe scroll X and Y is where it would define the direction that the water is going in. Let's say you wanted to go under the water and be able to still see from the underside of the water. Then what you would need to do, like I have it set, is in the material, which this will apply to all things that use that material, you can go under cull and you can turn it off. You could have it just be cull the front, which means you'd only see it from the back side. Or you could have it cull the back, which is the default setting when you first download it, and it will only render on the front side. So I set it to off so I can see it from the shader from both sides. So you can't see it. Now notice if I made it really squished, the waves get really squished. It could make it look like the water is moving faster, and we'll probably use that when we're replacing the water here. And if you see how it says top, you can, or right next to it has 3 lines coming from a point. If you click on that, it'll switch to isometric mode. So that's sometimes helpful to get your rotation down as well. One interesting thing you can do in Unity is you can press and hold the V key, and that will allow you to grab a vertice and then snap it to another vertice. So now I know that these two panels of water are nearly perfectly touching each other. Press the T key, and it allows you to scale almost like you're changing the scale of a rectangle. Now, if you press on the cube a second time, it'll go to perspective or isometric. Oh, one more thing to do before I forget is we want the Quest water to switch to PC water in PC mode. So we're going to go ahead and open up the Easy Quest switch again. We're going to go ahead and drag and drop that. Oh, instead of drag and dropping the shader, you're going to want to go ahead and drag and drop the mesh render. And then you're going to go ahead and have the material be switched out with PC water in the element. And then on top of that, you're going to have to get the Quest water settings to match the PC water settings. So I'm just going to quickly go back and forth about that. So I changed I'm not changing the diffuse, I'm not changing the specular, but I do need to change the cooling to be off. I do need to enable GPU instancing. And I did change the wave height. So now they're both the same in all of those regards. And so we should be good to go. So then I'm going to go ahead and force apply the PC settings and close out the tab. And now if I select this guy, it should be using PC water and look about the same. I had it set where it switches out the material on the mesh renderer. You're going to have to do that for every single plane that you have of water. So I'm going to go ahead and drag and drop this into here and drag and drop the PC water into here. And then I'm going to do the same for this one. And that would make sense why it's overly reflective, because what's happening is it's using the Quest version of the water in PC mode, which overcompensates for not having like post-processing and stuff like that. And then now that I've done that, I can just hit the force apply settings, and you can see that all of them now look like this nice PC color of water. Another thing to note about this water is it has a reflection mode. The default sometimes has these black spots. Not sure why. Maybe it's reflecting the gray building over there. You know, because when I'm facing this direction, but then you've got these black spots over here. And so it could be reflecting the ground underneath or something. But in that case, I will change the reflection mode to sky only, and it replaces those black dots for the most part with blue. Default, you can see those black dots, and sky only, nice and blue. Yeah, those sections might not pick up the trees, but blue sky is better than black dots. Welcome back. After testing in the Android platform, I found out that over time, this water would start getting what I would call jittery. And that didn't really make much sense to me at first, because why would as time increases, things get worse? So this is where it's helpful to have some background in programming, because it allows you to think through like, oh, this seems like a floating point error. where calculators will sometimes only have a certain level of precision to a certain number of decimal places. And at the beginning, the time variable in the shader for the water, it's only 5 seconds into the game, you've got 5.001 worth of accuracy. But as time goes on and you're like 2 or 3 minutes in, now you've got 300. Now you only have 300.01 accuracy. In one way, you can think of it as a floating point number, which you can see this is a type float, can only handle a certain number of digits at one time and can usually store how many zeros are after that digit to the power of, in essence. So how do we fix this water shader so it works on Android standalone on the Quest headset? Well, there's two options. One, we could try using Silence water shader. That's another option that supposedly works on a Quest, but probably is a little harder on that. Or we could try to fix his shader. And I'm going to provide the fix to Noriben's shader that fixes this minor issue in hopes that you use it so that you get more performance. So first, you probably want to go ahead and rename your water shader. So rename it to like 2 or whatever at the end, or V2 or whatever, like I've already done, with this one. Open it up, scroll down, and if you haven't installed Visual Code program, Unity will automatically ask if you want to install it to be able to see this code. So what you're going to do is you're going to go down here to line 133, hit the enter key and paste in this, or type it up. Half part of cycle, it's just a variable name I gave it, equal negative 31.85 multiplied by the arc tangent or inverse tangent of negative sine time dot x divided by cosine time dot x semicolon. And then I threw in this comment with the double slashes saying that the maximum cycle is 25-second cycle, going from negative 50 to 50. So if you ever wanted the cycle to go from -1 to 1, you could just divide this by 50. And if you want it to be like -0.5 to +0.5, which would be the smallest amount that would still be a complete cycle for like things like textures and stuff, then you would go ahead and divide it by 100, whatever this variable is in the front. Once you do it once, you're then going to need to copy and paste part of cycle into the next line that has height text, where it says time.y. You're going to replace that with part of cycle, and time.y replace with part of cycle. Rinse and repeat farther down just before normal map. Paste part of cycle, put it over time.y and time.y again. And that's the fix. Why does this fix the issue? Well, our big issue is that time is becoming too large of a variable to be able to do precise positioning of the water waves. What I found out on this crazy web page was that there's a sine time. What it does is it makes a sine wave based off of the time variable. What's cool about that is the sine time is always going to stay between -1 and 1, so you're always going to get really high precision at like 0.00001 or whatever. The amount of time that's passed in the world isn't going to change the how many digits of precision it can multiply with. So I asked myself the question, how can I use sine time, which sine is typically a wave function that kind of goes up and down and up and down. I want it to be linear. I want it to always be going up. So I'll go ahead and research, and I found out that sine of x plus y, which this is a graphable function, equals 0. And this would cause sine to be linear. So using a bunch of math, I was able to split sine x plus y into sine x cosine y, sine y cosine x. So this is the steps I went through to get the function into the proper format, where I needed to get either y or x onto the right side of the equation and then everything else on the left. I chose y as the one I wanted to get by itself on the right side of the equal sign. And so I've turned sine x plus y into this crazy function equals 0. Then I replace x with time. So sine time dot w, and then cosine time dot w over here. And so now we only have the y variable to maneuver. You're able to, if you subtract both sides by sine y times cosine time, then you'll get this equation where they equal each other. Just one's negative. If you divide both sides by cosine time dot w, then you leave only sine of y negative on this side. If you divide both sides by cosine y, now you've finally gotten it so all your time variables are on one side and all your y variables are on the other. So what's really cool is sine divided by cosine equals tangent. So we're able to combine those. I divide both sides by -1 to go ahead and get negative sine time divided by cosine time equals tangent of y. And you can use the inverse or arc of tangent on all of this to make it so that y is left all by itself. Great! I actually went into a graphing calculator to see what this looks like. And I'm just going to throw down a negative in the front. And you can see that it turned the purple sine wave into this really convenient, consistent, going from -1 to +1 in equal linear incremental steps. So if I go like this, you can see it gets almost to 1 and almost not. Now I did have to mess around with adding something in front and multiply it by. Otherwise, it arbitrarily goes from positive to negative, which is fine. That's why I added the negative in the front. And then it goes to like 1.56. That's where being able to use that crazy number, 3185, makes it go between almost -1 to almost +1, not inclusive. Another thing to keep in mind, like normally I would have just taken whatever this is in decimal format, but if we go back into Unity, we'll notice that the water material goes ahead and feeds a scroll y at any number between -0.5 to +0.5. And that's great and all. And by the way, if you want to see your water animate in the scene view, you can click Animate Materials, and I'll show you that crazy speed that we've now set it to. So if I bring it down to like 0.006, you can see it animates slowly. However, what will happen with this cyclical function that we've just made is if we go ahead and it will pop back down to -1 irrespective of how far along in the texture we are. Something to be aware of is if we put in 0.005, yeah, that's nice, slow moving water, but what's going to happen is some point in the next 25 seconds, it's going to jump because it didn't quite finish a full cycle of scrolling. There you saw the jump. A full cycle of scrolling through the entire texture of the water that it's just moving. So in this case, we can put down 1. So in the end, I wanted my cycle to go between +50 and -50. And so that's why I used this number in the end to try to do that. Another thing to note is we're using the sine time dot x and the cosine time dot x. Well, what is this x? So because if we go back to the Unity instructions, it gives us a float var. That means it's a float containing 4 different numbers. So if we were to access the first variable, which is notated as .x, then we would have the sine of time divided by 8. If we did dot y, we would have time divided by 4, dot z, time divided by 2, and dot w for just straight up t. Now, because if we go back to what a sine function looks like, it'll go between -1 at -half pi all the way to 1 at pi divided by 2. And so that is one cycle when converting that to this tangent. So if you add up the portion at the beginning of the cycle, which is -half pi and positive pi, it basically there's 1 pi of time between going from -1 and +1. Great. So the next question is, if we're doing time divided by 8 and running the sine on that, then that means that we have 8 seconds times pi to complete a full cycle. And that is 25.1327412 second cycle. So in that time, the full texture that's used for the waves has to pass through in 25 seconds. Otherwise, it'll just jump back to the beginning of where the texture started when the first map began, every 25 seconds. Well, hopefully that explanation was helpful. The end point of that is you can't lower your scroll Y or scroll X speed lower than 0.01. And then you're going to say, well, gee, when I set my wave scale to 1, that makes the water look like it's moving really fast. Can I do anything about that? I already stole my thunder. If you go ahead and increase the wave scale to 1.5, that should fix the issue. Ta-da! And because now each wave is a bit smaller, and thereby it, looks like they're going a bit slower. So keep in mind, you can't let your scroll speed go under 0.01, otherwise the texture will jump every 25 seconds. And you can always, to make the water look like it's going slower, do wave scale of 1.5 or something like that. Also, keep in mind that you're going to have to apply that not only to the Quest water shader, but you'll have to apply, Quest water material, but then you're going to have to make any changes you made to the Quest water to the PC water. So in this case, we'll change this to 1.5, and we'll set the lowest speed of 1. And so now, when I go ahead, and make sure whenever you make a change to your shader, so like let's say I change this by dividing by 50, just so you can see that this is going to change the normal map. It made the water scroll 50 times slower, besides the height, because the height and the surface are calculated in 2 separate steps. And see how the texture jumped there within 25 seconds or whatever. You have to go into here, and whenever you make a change, you just got to go to File, Save, and then when you come back here, the next time you open up Unity or select Unity, it'll update with the newest shader. So it's really easy to test and iterate and try things. Great. And then I've already uploaded it to Android. I've already tested it. It works, but you'll want to go ahead and re-upload to PC. That way the water looks pretty much the same between PC and Android. If you're at all curious about shaders and how to do them yourself, I highly recommend this tutorial series on YouTube by this author. She goes through a really good case study at the beginning explaining how current games do their different shader effects to make glowy effects and reflections and windows into other areas and how all that works together. And I found myself on more than one occasion just enjoying how the case study is explained so well. Not only that, but she goes into conceptually how the shaders work which is really nice before going into the nitty-gritty code. Unlit transparent cutout got replaced with this alpha blended. And so that's pretty much the same thing you do on trees that have alpha cutout leaves, where you would switch them out with the alpha blended. It won't look as good, but it sure will perform well. And once again, you can go look for this guy, silence filamented shader, which should be able to do transparency and run more efficiently on Quest than the standard shader. We've also, if you want to fix the ground or something in an environment so that it's not as shiny, you can always go into the smoothness and lower the smoothness. And now, boom, it's not as shiny as it was before. So that's something that I had to do quite often for the AltspaceVR default ground objects, where they wouldn't look normal unless you lowered the smoothness. Sometimes there'll be things like medieval characters that will have custom shaders where they specify specifically like the color RGB values in the custom shader. And so you can sometimes take, like, they had a material name that _ base that had gray colors, and you can drag and drop those gray colors into the albedo of the object. So let's say glass is the albedo in this case. So standard. I could drag and drop this glass onto the albedo, and that would change all my cups to this like glass color. That's one way to make those medieval characters at least have a gray color scale. If someone has a custom shader with a base. A lot of the particle effects I noticed had what was called legacy shaders. But again, the legacy shaders would be split into multiply, additive, or alpha blend. So you would just switch it out with the respective one in VRChat mobile particles, additive, alpha blended, or multiply. Sometimes I would found that like the material up here would be a default material, which I couldn't drag and drop or change to be able to put it in the easy quest switch and use standard light instead. So what I would do is I'd go ahead and every time you see a default material, you would just replace it with your own material. So I usually call it default dash material replacement. And then when I'm like, oh, you see these particles are using default material? Well, instead, I'm going to go, like you saw earlier, under the renderer. There we go. I guess if you go on the side. That way I could then go into the easy quest switch, which I'll go ahead and open up again. And then I could drag and drop that material into here and be like, oh, now I want this default material to go to standard light when I'm on quest. And then I could set it to enable GPU instancing and then go light. And there you go. Pretty cool stuff. But I'm going to go ahead and send it back to the fireball. There we go. There is a weird thing. Sometimes there'd be like a tree. I'm going to go ahead and close this tab. And when we replace the leaves with like VRChat mobile particles alpha blend, it would go ahead and give a purple tint to all the leaves. Not the pink color, like the texture doesn't work or the shader doesn't work, but just like a dark purple tint to everything, as if it switched from being grayscale black to white to this dark purple to white. So how I fixed it was I found out that it was the mesh that was responsible. So I went into Package Manager. I searched up FBX Exporter. FBX Exporter. I installed that. Great. So then I can close that. Let's say Mobile Sanctuary was the problem and like the ground was the issue. When I switch it to VRChat Mobile Particles, Alpha Blend, it's now got this purple tint. Then I go over here, right click, open prefab asset, and then go ahead and select the root of it, export to FBX, and it comes up with this crazy panel. I turn on embedded textures and export in binary format so it doesn't become super large, and I'd export into the hotfixes folder of the assets I'm currently working on. Export. Then I would go into Blender. Ta-da, Blender. Get rid of all these default objects. File, import, FBX. Import, because I know it's these two objects. I'd go ahead and open this up, get rid of everything besides these two objects. Huh. Kind of confused why I can still see this. Oh, it's this guy's. Okay. Well, this is the collision box. So if I go like that, there we go. So it only affected visually. So I would select, I'd only show the stage to fix that. Like if sometimes the trees would have multiple meshes because they'd have LOD1 and LOD0. And I would do one for each mesh. So then export, OBJ, and we'd call this the stage. And make sure your forward axis is set to -Z and your up axis is set to Y. Export, do the same thing for this flooring. File, export, OBJ, export. Great. So now we come back here, and you can see that this mobile sanctuary is what the FBX we had exported earlier. And what we do is we select the stage, and it has that purple tint. Okay, so then we go to our stage OBJ, just grab this mesh called default, drag and drop it, and you can drag and drop it from the side so it doesn't move you, and replace the mesh that was in here. And then I guess you would also want to replace the mesh collider in this case, so they're using the same, and then you would also move this to 0, 0 in this case, but normally you wouldn't have to change the component transform. And then we do the same again for this worship floor. Be like, oh, okay, so now I open up floor. You see this mesh. The mesh itself is default over on the far right. So now I can go ahead and drag and drop that in here. And then but I don't have to drag and drop it into the collider because it doesn't have a collider. And the transform components were already 0, 0, so it makes sense it would stay 0, 0. So that fixed the purple color thing, but I don't know why I had to do that. It's almost as if maybe it was that classic mesh being a non-finite value, and that really affects alpha blended shaders. And so being able to re-export it in Blender helps, but I don't know. It took me a long time to figure that one out. To get out of this view, if the background's this kind of blue tinge, you know you're looking at the prefab, and if you modify it, it will affect all instances of that in the world. You can get out by pressing this little button in the top left-hand corner. So now that we've done fixing shaders, which is a huge hurdle and the biggest step, we now get to go ahead and optimize the world. So normally, if you read any tutorial, you're going to want to bake your lighting, but I found that the meshes that were preserved by using the AltspaceVR World Preserver, some of them had non-finite values in them. So unless you want to go re-export the meshes with finite values using Blender or some sort of 3D modeling, you're going to want to just use real-time lighting. And if you're going to use real-time lighting, you can only have one light source, and keep in mind that the Quest headset can't handle any sort of shadows. So I just want to show you, it does say here, just after it compiled all my geometry for light mapping, took a while and a lot of my CPU, when it tries to go to preparing bake, it says failed to add geometry for mesh cross, mesh contains non-finite values. So you would have to open the mesh cross in Blender or something and re-export it so that it doesn't contain non-finite values, is my guess. But I've never actually tried it because whatever the problem is affects multiple meshes across the project. And what's intriguing is even if the object is not located in the scene, it will still throw an error. So for a while, when I was really, wanting to see if it was just a few objects that I could remove, I would remove like cross.001 mesh and see if it would compile. And then typically it wouldn't, and it would give me an error that this other mesh is now contains it just freezes, doing nothing but using up one core of your CPU forever. What you'll have to do is you'll just have to hit cancel. Now, just keep in mind, you can still bake reflection probes, and the non-finite value error won't affect that. This is the sad part where I get to go ahead and you see all these lights, all of them, all these point lights that I installed, I get to delete all of them. Don't want to delete the mesh of these hanging lights. I just want to delete anything that has like a point to it. Good thing I didn't delete lights, because that would have deleted all these meshes. Now remember, if you ever feel bad about deleting objects, you still have the ASVR Unity project. I noticed that this light model had actually been accidentally deleted from the scene. To be able to resurrect this light model that I had accidentally deleted when deleting lights, I was able to rename the current scene to version 2 at the end. And you can see that's what I'm viewing right now. I went into Assets, Import, Custom Package, went to Cornerstone VR Low Poly, opened that up, and then I was able to find, hit None, because I haven't deleted any objects, and I've been able to re-import this scene. Now currently I already have it, so it would replace my current scene. Make sure you don't do that. Rename current scene to version 2. And then you just have to make sure whenever you're working on your project that you're selecting the correct Unity scene file. So if you ever deleted like a mesh or a game object, you should be able to do that. Because then what you can do is you go back into the older scene and then you find the objects that you want to bring over. So in this case, this lamp. Click the first one, hold shift, click the last ones to group select everything in between. Right click, copy, go to your newer scene, and then right click, paste into whatever area of your hierarchy you want. Now, back in the AltSpace days, normally there would be one directional light, but one of them was set to, I think it was some layer, whatever stereo left is, maybe layer 14. And that layer was supposedly where all kit objects resided. So that way kit objects could be lit using real-time lights. And then you have another directional light that would handle all your light baking. So in this case, because we're no longer having baked lights, I'm just going to get rid of this sun baked. And I'm going to go ahead and leave in this sun avatar. I'm just going to call it sun, because it's our only sunlight now. Now you're gonna say, well, now that I've removed all these lights, it's so dark. Like, you know, how can we make the ambient light brighter in this environment? So you can go to Window, Rendering, and Light Settings, and you can change these three options. Sky color will change how bright things will look from above. You know, and I'll bring up this little color palette, and you can see it'll mess with the surfaces that are facing the sky. Equator color will mess with the surfaces that are like seen from the sides. And then the ground color will mess with surfaces that are looked from the bottom. So notice how dark these undersides are for these trees. If I go ahead and raise the color, they get real bright. But the top surfaces don't, and the side surfaces don't change so much. So I usually do like a pure white, and then like a bright gray, and then like a darker gray, you know, to give this effect of where everything's lit, but there still is like the things that are facing the sky are still brighter. I'm going to decrease the, make things a bit darker, just because I guess my different, maybe it's the shininess value or something, but things seem to be very bright defaultly in this world anyway. So if you go down here, shadow mask used to be a way to do all of this, but I'm just going to uncheck mark global illumination, baked global illumination, and that'll disable all this baking ability. Go ahead and save. If you select everything but VRC World main camera and post-processing volume, you can go ahead and make them all static. However, because I've had issues with, once again, those non-finite values in meshes, I have to turn off batching static. Now don't worry, we're not losing a big hit in performance because we have GPU instancing turned on for every single shader. And so that will still try to batch them on the GPU side of things. The reason we want to turn on the static baking is we're going to go ahead and use occlusion culling. Let's see if I can remember where it is. So Window, Rendering, Occlusion culling. And what this feature does is it allows the computer to say, if you're in this block area and you're looking in this direction, then don't even think about rendering all the objects that are either behind you or are blocked by objects in front of you. For interior scenes, I find the smallest includer of 1 is a good value instead of 5 for under bake. You're going to want to go under Object tab of occlusion, and then you're going to want to go to occlusion areas, and then make sure you're not selecting anything. In the main panel, if you hit occlusion areas, it'll give you the option to create a new occlusion area, which will go ahead and place that at position 000. So go ahead and make it a bit bigger. And then this is when using the isometric mode is super useful. So you can click one direction. I want to look straight down. And if you click in the center of the cube again, it'll switch you into isometric mode. So now it can be like, okay, this area, you should select the entire area that's considered walkable. And so you can't rotate the cube to match the same, where the land is, but that's okay. It doesn't take a lot of extra processing power to render, to do this outer area, and you only has to do it once while you're, editing it. So now we're going to go to a side view to make sure that we're, vertically selecting everything. So we're just going to assume that people are going to want to stand on the trees a little bit, because they're going to have special avatars to be able to fly or something. And we've now just selected that. To get out of isometric mode, you can go ahead and press the center of the cube, or you can also press on this thing that says ISO versus perspective. And there we go. That looks like a pretty good area of selection to be able to walk around. So once you've gotten that, you can go ahead and hit this button bake. Expect it to take some time loading. The loading bar is going to be in the bottom right hand corner. It's going to take a lot of CPU to do it. Hypothetically, you can also watch the scene view, and you'll see all of a sudden it's pegging my CPU, and these are every one of those boxes. It says, okay, if you're in this area, these objects, all the trees back here don't have to be rendered because they're behind a hill, for example. Or all the chairs don't have to be rendered because they're behind walls. So this will greatly increase performance for worlds that have a lot of indoor environments, and will mildly improve worlds that are like giant landscapes, where it reduces the GPU load. Okay, so when it's done, it will try to show you like, okay, what objects are being rendered when the camera is placed right here. So you can see these chairs are being rendered, but none of the other chairs are being rendered. And so it takes 8 megabytes, but that can be totally worth it, especially if you have the extra space in the world. I would always take more space out of the textures to save your space elsewhere. So it looks like, so if you don't see objects pop in and out of existence, you're good. So you can see here, when I look up in an awkward angle, you can see the chairs kind of start disappearing, but I have to be like absolutely in the corner. So we're just going to assume that people aren't going to hug the corner like that. But that's a great example of what we're looking for. Is there any sort of area where things that should be there aren't there? So there have been cases where indoor areas have just completely disappeared, and I'm going to show you what you would do to be able to fix that. If Unity decides that an indoor area is not walkable, it's not accessible, it'll decide, okay, well, even if you're inside this room, since no one can get in it because of the collision boxes and stuff, I'm going to go ahead and make it so that these objects do not appear, or are not visually seen. So let's say, for example, this tomb, right? If you were to go inside of here, it probably would have a hard time showing you what's inside. So to fix it, all I do is I go up here, I uncheck mark occluder static. So that means it's no longer going to act like a blocker. It's going to be as if when it's processing all this, that people can see through this stone to see inside. And if people can see through this stone to see inside, then it's going to go ahead and keep making those things inside visible. On the flip side, there has been an occasion where a character, like, what's his face? I'm going to go ahead and return this check mark. An animated object was moving and had the eye as a separate object. And that eye would actually disappear at certain angles because the rest of the face blocked it at certain angles. But then when the animation would have the person turn the head, then all of a sudden those angles no longer apply. So you could, at a certain point during the animation, if you're standing at a certain angle, the eyes wouldn't be seen, which was a very funny experience to see that. Let's say this like door was made to animate or something and to swing all the way back and forth. What you could do is you can go ahead and uncheck mark occludee static, which would mean that it's always going to be visible no matter where the person is in the world. So it doesn't follow the rules of, oh, this wall's blocking me, don't show me at all times. Whenever you make one of these changes, you would have to go ahead and go back into occlusion. I personally hit the clear button and then bake. If you really want to visualize how it's making its calculations, you can click this little check mark that shows the visibility lines, and you can get a sense of what collision meshes it's hitting and deciding, oh, I don't need to render all these logs back here because of all the collision mesh lines hitting the stage. And again, you would have to move the camera object to get a sense of, what, while in the occlusion visualization panel, to see like, okay, these chairs are disappearing or appearing because of these visibility lines. So you might want to just make a duplicate camera object. And so you would go into here, duplicate, and then use the duplicate camera object to visualize everything. Visibility lines. There was a haha moment where you can see right here, there's a tree right there that disappears and appears right when the view screen would start seeing it. View screen being down there. So why is that tree different than all the other trees? So I click on the tree, click on the inspector, looked at the mesh, and realized that the way that the AltspaceVR World had been preserved is it had taken some meshes and combined them. So this was combined mesh 11, whereas pretty much all the other trees happen to be on the combined mesh 10. And again, since they're all these trees on combined mesh 10 are being rendered together, that means that as soon as one tree from combined mesh 10 appears, it will draw all of them, regardless of whether the tree is behind or in front of the camera. Objects that have been added, like kit objects, will each individually appear and disappear, or objects that have their own meshes will appear and disappear. So if I go over to this chair, see it has an individual mesh for a chair. However, if I go to path and click on this combined mesh, you can kind of see in the thumbnail that it's like a giant squiggly line of multiple paths. So if any one of those paths is seen, they'll always be rendered even after doing occlusion culling. So don't be discouraged if occlusion culling seems to be only helpful for making the kit objects disappear. That will still improve performance. Another thing I learned is that the occlusion bake smallest occluder means how large does the object have to be considered an occluder. So if it takes up like 1 meter cubed of space, it will then be considered worth blocking other objects, which I think is a good number. If you increased it to like the default 5, some walls might not be tall enough. Only like mountains would be blocking things, in my opinion. But that's just my opinion. You can always play around with the small occluder size to your liking, and that'll obviously change the occlusion data size and so on and so forth. So this is an example where, remember, we made these occluder static and occludee static. Well, because when they move, when my view looks away from where it was originally resting, it disappears. See? Boop, boop. And that's because it's not expecting this object to be picked up. It's expecting it to be static. So we'll have to turn occlude static off for the swords, spears, and rooster. So for these roosters, this one that's standing on top, go up here, click on it, occlude static. I'm going to turn off. I'm also going to turn off occlude static, which means that it would block things behind it. But we don't want to do that because let's say it blocked something behind it and you picked it up, the thing behind it would still not be present. And most of these other things like navigation static, reflection probe static, contribute GI, we should turn off all of those. To me, the easiest way to turn them off is to check mark it all and then check mark it all off. You can go to the hierarchy panel and you can select all the swords by clicking one of the swords, holding shift, clicking the bottom sword, and then uncheck mark them as static for all of them. Same with the spears. And we're going to make sure we've done that to all the other objects we can pick up, like these cups and wafers. And now, if we go ahead and test this new bake, we should be able to pick up these spears and take them with us if we want. I will admit that these roosters are falling over, so I might switch out their collision mesh with a collision box, so that way they stand upright. Test to see if my new box gliders on the roosters will make sure that they stand upright when you first see them. And they do. Now that we've gone occlusion culling, you can go ahead and for the size, do a mass texture importer. So up in VR World Toolkit, quick functions, mass texture importer, bring this over here. And first of all, VRChat likes streaming bitmaps on and generate bitmaps on. So that's already something that should be a benefit of running this. You can get you have to click this scene button so that it will change those textures. And I only click scene because I only want it to run on things that are actually in the scene. Go ahead. I use ANSO level 8. I set the max size of textures to 1024. And then I set the crunch level to 20. And then I set it so that the Q maps can't be larger than 128. Then I go ahead and hit apply. And it may take a long time depending on how fancy your textures are. A lot of my textures in this world are all 1 pixel textures. And that's just because I didn't fully understand how to optimize materials. Word of advice: the fewer materials you can have in your scene, the better. Ideally, every object should only have 1 material, because Unity can only batch drawing multiple objects together if they have the exact same material sets. And so if you had every single object in a scene using the same material, guess what? Now it's only 1 draw call, and it's going to be like 2 or 3 times as performant as anyone else. However, you're going to want different shaders, and that's when you would want different materials. And so then ideally keep the number of different materials under 25 for AltspaceVR back in the day. But realistically, VRChat can handle a lot more than that. And what we're going to go ahead and do is we're going to go back into the Windows mode. Switch platform, Windows. And this should run a lot faster because you set it up so it would cache your Windows setup. I'll be really curious. Just to be safe, I go back to the Quick Functions Mass Texture Importer and reapply the same settings. On the entire scene. So that way I know for certain that all the caches on both the Windows version and the Android version have these new compressions applied. So then I go ahead, and this is the big moment. You get to go into VRChat SDK, show control panel, and you get to log into your account. You'll notice that they do require double authentication now. So once you go ahead and paste in your authentication code, you can then go ahead and go switch to the Builder tab. And you can find out, that it complains that found 3D audio source with no VR spatial audio component. So you can go ahead and hit autofix, because that makes things a lot easier. And you can just press it for how many audio sources there are. And in this case, I can just press AAU. The one thing I do like to do is under advanced options for the VR spatial audio source, I like to use the audio source volume. I should expand this. The audio source volume curve, which is seen here, because usually that was perfectly calibrated to make it so you could hear it within a certain distance or whatever. So I'll go through and change all of these. So now if we go back to our control panel, we have no errors here. If you want to be extra careful, you can go to the VR World Toolkit, World Debugger, and it will also provide its own set of recommendations. So it's going to tell me to take the value gets clamped to between 0.01 and 0.05 for the camera. It's only useful in the sense that it's useful to see, like, if I move the camera around the scene, how soon would I be able to clip through walls, kind of thing. It complains about the collision culling cache. I never auto-fix it because I like the cache. But you can leave that. It talks about considering baked lighting for improved performance. As long as you're, using simple shaders and only have one directional light, real-time lighting seems to work just great. The current scene has no active reflection probes. I'm going to re-enable my reflection probes. Boop. And you'll notice the water turns to this ugly black because none of them have been baked. I'm going to save. I'm going to try and bake this one. It worked. So we're finally at the big moment. Now that we've baked our stuff, we can go ahead and show control panel, go back to the builder, and then we can do a build and test. So I recommend always doing a build and test before you upload, just because you want to make sure that you're doing a good job. And what will happen is once it's done, it will go ahead and create a window, or you can test it in VR if you left the force non-VR unchecked, that you can test. Now, just FYI, it will use VRChat that's locally on your system. It will then use the credentials from the Unity uploader that you logged in with to be able to log in with that account inside of VRChat. Any settings you change here will change the settings you have inside of VRChat proper, which I think is kind of interesting. Like if I change the avatar here, it will change the avatar in VRChat proper. And if I go into the settings and change any of these settings, it'll change the settings in VRChat proper. Assume that you're happy with this. I'm happy for this for first iteration, but you can always re-upload a new and updated version. So you can actually find out, it's like, oh, I want to find out how large of a world that is. So if I open up the world debugger again and go to build report, or I don't even have to go to build report, it'll show that it's 18 megabytes total for the Windows build. If you go under the build report, you can see what asset is taking up the largest size. Now I'm going to tease you that if you start adding these up, 8 megabytes, 8 megabytes, 4 megabytes, 2, you're already at like 20 megabytes. So the added value of all of these below is not going to equal what's up here, because what's up here is if you took all of these files and compressed them together in a zip or some sort of compression. And there was only one warning during the build about a script being missing, so you can always fix that by deleting the script component. And I guess as good practice, go ahead and click on this. Bake all reflection probes. And when you're ready to submit your first world, you can go ahead and build and publish for Windows. I always recommend doing Windows because then you can easily test on your computer inside of VRChat. So this does it in 2 steps. The first step is it's going to compress everything. And once it's done with that, it's going to greet you in the scene panel, surprisingly, with an area where you can tell it exactly what you want. I'm kind of surprised because I guess it's designed very specifically for an HD screen. So I'm going to go ahead and temporarily move the console and the project panel up here so I can see the full window. This is where you can define the player capacity. 40 is the highest that you can set it to. Technically, you can get 80 people in a world by having people join other friends. And you can check mark the above information is accurate, and I have the rights to upload the content to VRChat. And then do know that if your VRChat account is a visitor trust rank, you will not be able to upload anything to VRChat. If your user is a new user, you'll be able to upload, but only as a private world, and you'll have to take the world link and send it to people for them to be able to invite themselves, or you'll have to be the one to create the portal because no one will be able to keep your private world in their favorites list. You'll have to be the one to create the portal or go to the world yourself and then send people invites. If you are a user rank, then you can publish to community labs, and it'll put a little warning to anyone entering the space. This is community labs. These worlds could be, may not be trustworthy, meaning that they could hack you or crash your computer or whatnot. If people visit your world that's in community lab state, then what will happen is eventually that marker will remove when you get enough people visiting. It seems to remove quicker when you get groups of people visiting your community labs world, as opposed to just having one person stand in that world for a long period of time. Anyways, I'm going to go ahead and hit upload. And since everything's already been compressed, it's just a matter of how long does it take to upload that 20 megabyte file in this case. Once it's done, it'll bring you back to this page where you could then build and publish again if you wanted. And then it'll say content successfully uploaded, and you can hit the button to manage in browser. it takes you to the world's page. Now you're going to say that thumbnail looks terrible, and we're going to go ahead and update it when we're uploading for Quest. You could send this link at the top to be able to access the world, or better yet, you can take this link where it says vrchat.com/home/launch ?world ID equal, paste in the world ID, and this people can see even if they don't have a VRChat account. So I always send this one, and this has the button very conveniently right here that says invite me, which then people can use to, like, they put on their Quest headset, they log in, they're in VR, they pull this link up on their phone, and then they can press the invite me button if they're logged into VRChat. And then when they go back into their headset, they'll see under their alerts a invite request from themselves to go to this world, this public instance of the world. So the last step is to go ahead and switch. Now, I know it says that you can switch the build target here, which will switch you to Android. However, it has been known to have issues, according to some people a year ago. And so it's better to go to File, Build Settings, Android, Switch Platform. So now that's finished that. We're going to go back into the control panel, go into the builder. Notice you can't build and test, and it'll also tell you of any issues you have. Even though I have silent, clear, water, cheap, URP inactive, it complains about that. So you can go ahead and switch that out with like the default. I'm going to go ahead and do that. It talks about how Noriben's technically not supported. It thinks somewhere in the miasma of materials that one of them I haven't changed to standard. TextMesh Pro seems to work just great. Unlit looks just great. And the Alpha Blended was created by the VRChat team, so I would trust their work even though if they don't trust it themselves. Let's say you went through every single object and you still didn't find every single standard shader, and so when you go into Android, it says the world uses unsupported shader standard. This could cause low performance or future compatibility issues. You can always go into the VR World Toolkit, World Debugger, and there should be a message that says found 20, some number of materials with unsupported shaders. You can expand that and ignore the ones about like alpha blended or unlit color and find the one that says standard. Apparently it's the chandelier metal. So there's two ways we can go about it. One is I can go into the, scene and be like, oh, I think that the chandelier metal is this. So if I click on that, it should show in the inspector panel, aha, we have our chandelier metal standard. The other way is if you pull up your project, menu in the bottom, you can then go ahead and search in the bottom right hand corner, chandelier metal, and it should appear, and then you can go and change it from here. In this case, because I do like the idea of it being reflective, just not that reflective, I'm going to set it to 0.7. I'm going to set my metal to 0.5, and then I'm going to go into Window Easy Quest Switch and place that there. Drag and drop this guy. I guess I can drag and drop it down here. And then I can switch it to standard light. And then change it here. Ta-da! And if we're lucky, we should be able to, now we have 26 materials. If we go back into show control panel, guess what? The standard shader it's no longer complaining about. So Another way to find those nuisance shaders without having to go through every single object. I'm going to go ahead and hit build and publish. This time, I'm going to show you how to set up the thumbnail. So you're going to have to check mark upload image, right? And if I go into scene, you'll notice there's a new camera here. If I go all the way at the bottom of the hierarchy, there's a new scene called Don't Destroy on load. And there's also, just above that, the VRC cam. This is the camera that actually takes the thumbnail image. And so we're going to go ahead and take this camera, copy its component, its transform component values, go over to this camera, and paste component values. Bam! So now, when I go back to Game tab next to the Scene tab, you'll see that the camera that we moved now sees this screen with the little chairs and the little chandeliers and the stage and the cross. So now that we have this upload image checked and the above information is accurate, we'll go ahead and hit upload. And this is uploading for the quest. You'll notice while we're waiting that right now the world says PC only on the website. Content successfully uploaded. And so if we go back to our browser and refresh the page, it now says cross-platform. Also, don't forget to test on a Quest headset or get a friend who has a Quest headset to test, because you never know what issues may occur in standalone mode, not Quest Link with a computer, but standalone mode. And you'll want to ask specifically what are the frames per second the user is getting. And if you want to know where you can turn on frames per second in your panel, I will show you in desktop mode. You would go into your menu, the mini menu, go into settings and scroll down all the way at the bottom where it shows frames per second. And there's an option to pin FPS and ping. And that will then pin the FPS in the top left-hand corner so that the Quest user can see what FPS they're getting. Ask them to check their FPS in different areas of the environment, because depending heavily upon where the user's looking might determine the frame rate. Let's say inside the building, the frame rate's great, because our occlusion culling gets rid of other objects. But then when he gets to an outdoor scene with a bunch of trees, all of a sudden his frame rate drops down to 40, then you know that the trees are causing the issue. Maybe it's the leaves, maybe it's the number of trees, maybe it's the alpha transparency of the branches because they're using flat textures for branches instead of 3D meshes. Who knows? But at least that helps you narrow down what is causing the frame drop. And if you have a Quest headset, it makes it much easier for you to do your own testing and slowly change things. So now we have uploaded a Quest and PC compatible VRChat World in VRChat. So just to demonstrate, your newly uploaded world should appear under Worlds, My Worlds, Uploaded. And you'll see that it has the blue and green in the top right. It says that it was published today. It says the world size. It says your author and all that. Now, if you tried to add it to favorites, right? We'll try like favorite worlds. So this is what they'll see. If they are able to favorite it at one point, like let's say it was public and you made it private later, this is what they'd see. They'd say the world currently set to private. You no longer have access to it. Would you like to remove it from favorites? When they click on it, and then they can hit yes, and then it'll be removed from favorites. Normally, though, when they try to hit the add favorites button, it'll tell them you cannot favorite this because it's a private world. So you can always create a new instance and do the normal friends plus, invite and all that. But enough of me talking, let's go into the environment. And ta-da! We have the world. Yes, we have a fast movement speed. Yes, there's a lot of shaders that are reflective, but those are all things we know we can fix. So congratulations on making it this far. Thank you for watching this wonderful episode, a very long one on how to convert AltspaceVR Worlds to VRChat. And I hope that maybe, just maybe, this helped you learn a little bit about how to use Unity in the process. Congratulations. I hope this takes you far. Bye.